So for this video, we're going to talk about how to deal with inequalities, specifically around Algebra 1 levels of solving inequalities or graphing in one variable or two variables. I have two different examples we'll go through pretty quickly, and I'll try to talk about some stuff that might not get hit in just one example as well. For the first one, I asked that we solve, then graph. So solving. To be able to do this, we need to be able to solve this equations before we can get into inequalities. So I would treat those essentially the same way. I like to think line down whatever our symbol is, so that catches both the equal sign as well as the inequality symbols. And then we want to get our variable, so x, so that it's the only thing on its side of the symbol. So to do that, I'm kind of undoing those order of operations. So I want to get rid of subtraction first. So I'm going to add 16 to both sides. That's both sides of that line we created. When we do that, we're going to be left with just 2x. I use the same symbol here. It's going to stay the same in almost all circumstances, so I'll touch on that in a second. 2 plus 16, that gives us 18. Next, we want to get x by itself still. So if I have a number and a letter next to each other like that, that means multiplication. So I need to divide on both sides. That leaves me with x less than or equal to 18 divided by 2 is 9. So to make sure I'm at the end here, I have a variable, my symbol, and a value. It's kind of a three-part answer is how I like to think of it. The one thing that I mentioned that it could change, if we were getting x by itself by multiplying or dividing by a negative number, so say this was a -2 instead, when that operation happens or when that undoing happens, this symbol gets flipped around to kind of compensate for a sign change. Now that we have this, we've done the first part of our question. We also want to graph. Because there's a single variable here that tells me when I'm graphing it's going to be on a number line. I like to mark 0 as kind of a midpoint. Sometimes you'll be asked to show every mark. I'm a fan of just jumping to whatever my specific value is. So I know 9 is going to be on this side of 0. I'll label that as 9. If I wanted to, I could make each mark along the way as well. For graphing on a number line, I'm going to need a circle above whatever value, and then I have some questions to ask. Is it open or is it filled in? Open is if I do not have this line underneath, meaning that that value itself does not work. If it's a case like this where I do have the line underneath saying it could be equal to, that means that 9 itself can work, so I'm going to fill it in. So that's part of it. I also have to determine if there's an arrow coming off to the left or to the right of that circle to denote less than or greater than. Here I have x less than my number, so my arrow comes off to the left. And what that does is it shows that any number that is 9, because that's filled in, or less than would work if I were to plug it into either my answer or the original, either thing. So 0, for example, falls under that. If I plugged in 0, 2 times 0 is 0, minus 16 is -16, which is indeed less than or equal to 2. So when you're graphing in a single variable, it looks like a number line. Come over here. For my second one, graph, and give an example of a point that satisfies the inequality. So I'm going to have a full coordinate here at the end. If you notice, I have two variables here. So graphing in two variables is closer to slope-intercept form. We're going to be on a coordinate plane this time. We're going to graph just like it is slope-intercept form, or y equals mx plus b. So this is our starting point, our y-intercept. I'm going to start up 1. This is my slope still, so up 3 over 2. So 1, 2, 3 over 2. I know it's not going to be perfect when I just have a kind of makeshift coordinate plane up here, but it'll do for what we're doing. Before I connect them, this is where I have questions just like last time where I have to ask myself, instead of an open or closed circle, I'm going to ask, do I connect with a solid or a dashed line? Solid is if I did have the line underneath there, dashed is if I don't. So in this case, I don't. So I'm going to connect with a dashed line. What that tells me is if I have a coordinate that falls directly on that line, it will not satisfy this inequality. If it was solid, it would. And then finally, I have one more question that instead of having an arrow coming off to the left or coming off to the right, I need to shade above or below my line based on my symbol. So here it's greater than. So greater than is going to tell me above. If it was less than, it would tell me below. So anywhere infinitely above that line is greater than. So any coordinate that falls anywhere in this shaded region, all the way out to here and beyond, I can't reach very far, would satisfy. So for example, 0, 1, 2, 3 falls in that region. So one coordinate that should satisfy would be 0, 3. So if we tried that, 0 times this would be 0, plus 1 is 1. 3 would be greater than 1. So we have to plug in an x and a y, and that does satisfy. So there's kind of an infinite amount out here that would work. So hopefully this helps. It shows a couple different things: how to graph, when to graph on what circumstance, and then how to solve this.